Okay. Hi everyone. I'm Eduardo, and I'm a software engineer. First of all, thanks for coming here to watch my talk, and thanks for the organization to accept me as a speaker. Um, so my talk is entitled "Replication as a First-Class Citizen: The Art of Global Resilience." Just reading it out loud in case someone came to the wrong room unexpectedly. So today I'll be talking a little bit about my experience in developing applications that are deployed into multiple regions, but also we're going back to review some basic principles of resilience, and then see how and why would you want to deploy an application to multiple regions. So pretty much every service, or a lot of the services, start like this, right? So a very simple instance of a service that uses a database and that has some clients. It might be some HTTP endpoints. It might be that this service actually serves simple HTML, but something like that. So if you want to make this service as resilient as possible, usually you would try to avoid single points of failure. And then to do so, you're probably going to start by just, instead of having a single instance of your service, maybe you have multiple instances of your service. In this case, you can have 3 instances, and then you just put a load balancer in front of these 3 instances, and make sure that with this load balancer, if you have one service, one instance of these services that goes down, your load balancer will make the job of redirecting the traffic to the ones that are still up, so you're still available to serve the traffic and your customers, I guess, right? Of course, after your service, you still have the database. So if you want to make the database not a single point of failure, you'll probably end up with having some kind of another instance of this database and do this replication from one side, from one instance to the other database. It might be that you decide to serve all your traffic from this instance that you have, which is usually called the primary, and then have a standby database that it's only basically for when something goes wrong with this primary database, you just fail over to another database and are still able to serve your traffic. Okay, so in this picture, we probably still have one single point of failure, which is the load balancer. We cannot forget about that. But for this talk, I'm assuming that even on this load balancer, you probably have two instances of the load balancer and you are able to fail over. So lastly, if you want to make sure that these services are as resilient as possible, you want to make sure that you deploy these different instances, both of the service and of the database, in different zones. So if you are in the cloud, these might be different availability zones, but the principle is actually the same. If you are deploying on-prem, maybe you want to have this distributed across different hypervisors. If you're using Kubernetes, you want to use different nodes. The main point is that you want to make sure that these different instances of your service are distributed across different physical locations, basically, well, physical hardware. Okay, so of course this is a fairly simple service, but it's good because some of the principles that we are using here already are kind of similar of the principles that we use when we want to deploy a multi-region application. For instance, we are kind of using a pattern on the service that it's kind of active because we're just distributing the load across different services, and there on the database we're kind of using an active passive because one single instance of the database is serving all of our traffic, and then we have one that is only waiting to come up to service. Of course, you might say that a more realistic scenario is some service that has also some third-party services integrations. It also integrates with some old legacy service. Maybe instead of only writing to the database, it will also write to a message broker. Obviously, this would be a more realistic scenario, and maybe in like a lot of cases, it will be more about different services connecting and not only one. But we'll get there. Okay, so if you have this application or this service and you did all this is as resilient as possible on a single region, there is still a chance that if there is a very catastrophic event on that region, you might not be able to serve your customers. And one good example just happened a few months back, right? So when there was this big electricity shutdown in Portugal and Spain, it's not something that happens often, but if it was the case that your customers, your services were hosted on a data center in Lisbon or in Spain, most likely you wouldn't be able to continue running your business because everything pretty much shut down. So this is not something that happens often, but it can happen. So for some types of businesses, it might make sense to try to avoid having downtime when something like this happens. So what are some of the good reasons or some of the reasons that you might have to go multi-region? So the first one is actually what I just mentioned. You want increased availability, so you want to make sure that you survive catastrophic events on a single region of the planet. So that might be one obvious reason. Another one is because you want to have consistent low latency globally. So if you have customers both here in Portugal, in Europe, but also have customers in New Zealand, but also have customers in America, you might want to make sure that the interactions your customers have with your services are as fast as possible, or having low latency. So you want to distribute your data in that scenario. Might be another reason. And another reason might be regulatory compliance. So there are some types of businesses, could be financial or healthcare or other types of business that actually force you to store the data in some specific regions where that data belongs. So these might be 3 good reasons to adopt multi-region. And an extra reason that is actually, well, more like a theoretical reason, to be honest. In theory, it might be the case that you are deploying under a specific region and your business is so big that you are already at the limit for some regional service limits and you just want to distribute your traffic across different regions. Again, this is more like a theoretical. There's probably like a handful number of companies that will face this issue, but it's a theoretical reason that you might have. So how do we go multi-region? So we'll talk a little bit about these 4 things. You obviously need to have some goals and know your goals. You obviously need to understand your application that you're deploying, understand its dependencies, and your operations. Okay, so about the goals themselves, it's obviously you need to understand exactly why are you doing this, why are you going to deploy an app to multi-region, and some good ways to, or some ways that people use to measure exactly what are the goals could be this mean time to detection, a mean time to recover, a mean time to between failures. So the mean time to detection is basically from the moment in which an error happened until the moment that someone notices that it happened. It's the mean time to detection. And then the mean time to recover adds the time that people noticed it and tried to fix it, if there's a fix, or fail over to another DC or another region and actually got the service up and running again. So we obviously want these mean times to be as low as possible. As low as possible. And one interesting thing is that if we think about 4 nines availability, that means that a service, if one of the goals is for one of your services is that you have 4 nines of availability, you have more or less 53 minutes of downtime allowed per year. So if you think about if you've been on call and you think about the time it takes for a person to get notified that the problem existed, which means that some alert was already triggered, got to your phone, you got to the computer to kind of understand what was going on, and then actually maybe you talk to another person to see if you want to do a failover or not. It's really not that difficult that in this span of time, you already lost 30 minutes or 35 minutes or 40 minutes. So if you have a goal like this of 4.9's availability, the quickest option to actually get your service restored might be to just go ahead and file over. Instead of obviously trying to find out what the problem is, it might be that you simply want to say, okay, I just want to fail over and have the things working again, and then I'll try to figure out what happened. So it's good to obviously know exactly what you're trying to do. Now, the other obvious thing we want to know is exactly identify inputs and outputs of your application, of your service, understand how your behavior affects your users, how the behavior of the app affects your users, and we'll have a look at data consistency requirements and data access patterns. And also, you need to ask yourself, is this application already as resilient as possible on a single region? Otherwise, we probably want to make it as resilient as possible on a single region before you try to go to multi-region. So if you have a look at this service again, it's kind of obvious, the inputs that we have, probably the client, the third-party service, the legacy service, and the outputs will be everything that we write to the database, the message broker, maybe something that we showed to the user as well. It could be the output as well. Now, when we are trying to analyze this application, it's also good to think about in terms of if we want to choose availability or consistency. So if you worked on this kind of issues, this is probably a known theorem for you. So CAP theorem says that if we have a distributed data system, we can only pick two of these three properties. So partition tolerance is the possibility of the system to continue working even if you have failures in the network. Availability is the possibility to continue responding to your requests, and consistency means that all the nodes from your system see the same data, have the same data, or all the clients see the same data. So basically, since you cannot ever guarantee that the network will not fail, for these types of systems, you need to decide basically if you continue to serve your clients. So say if you have the database there, and the primary database goes down, you basically need to decide if you fail over to the second database and serve from the second database, and then the two databases will get out of sync, but at least you're serving your traffic, so it's fine. You're compromising on consistency to have availability, or otherwise, if there are some cases in which you simply might decide that if I lose a database, I just don't want to have any inconsistency, so I won't serve traffic. So it's going a little bit into detail about this replication that you use between databases. There's two types of replication that we can use. So the first is synchronous replication, where if you see when there's a request from the client to the service, that service writes something to the database. If we're using synchronous replication, what this means is that the write will get forward to the replica database, gets the acknowledgement for the database, and only then will then reply to the to the customer, right? So we receive the acknowledgement from the replica before replying to the customer. This obviously means that we have a strong consistency guarantee, but there's a lot more latency on the writes, and there's a performance penalty also. So our database will have less throughput. And this synchronous replication, it's usually not used when your data nodes are further apart than 100 kilometers. So if you have, say, I don't know, two data centers, one or both located in Porto, for instance, maybe you can have this synchronous replication between two data centers. But typically, if you are deploying to Lisbon and you are also deploying to Frankfurt, you you typically won't use synchronous replication, just because the latency will make things harder and slower for the user. So then, for those cases, obviously you can use a synchronous replication. And what that means is that once you get a write to the database, as long as this write is written to this database, you can reply back to the client, and the replication will then catch up and send that information in parallel or afterwards to the other replica. Of course, the problem here is that if you acknowledge that some information was actually written to the database and you sent that to the client, but then this database goes down and you have to fail over to the other standby database, then your user might not see the data that it just written to the database, right? So you are at risk of having some data loss. And also, if it is the case that you're serving traffic from your replicas as well, it might be the case that your clients won't see whatever they wrote right away. So there's eventually consistency. Okay, so another thing that we want to think about on our apps is the data access patterns. So is our app basically read intensive or write intensive? So say if you are building a URL shortener where someone goes and creates a short URL and then shares that around and people will just go ahead and do some reads, this will probably be a read intensive system. But if you are doing a system that, I don't know, tracks down financial markets and things like that, this might be a write intensive system. And this will be important for you to choose exactly what type of architecture you'll use for your case. So for instance, if you have a read intensive system and you want to use an active-active architecture, which means that you are interested in serving requests globally across the different regions that you might have, you might have a read local, write global strategy. If you only want to have an active passive strategy, you just always go to the primary region. And we will see in detail what exactly this means. But in this case, it's like you basically have one active region that serves all your requests, but then you decide that you also want to have like a standby region, because if there is an issue with this primary region, I want to be able to fail over all my traffic there. Okay, so let's see in more detail what does this mean. So if I have a read global, write global architecture, and I have a customer in Portugal and a customer in New Zealand, and I have this global routing here, what this will do is any kind of requests, be it a read or a write, will be forwarded to my primary region, in this case, Europe. Okay? So this is fairly simple to understand. I'm just using an active passive architecture there. My active region is Europe, so all of my traffic is going there. And of course, I will need to have some kind of replication across my regions, in this case from my primary to my passive region. And yeah, if I have a problem eventually on this region, I'll just want to make sure to fail over and have this global routing pointing now to the Australian region and serve my traffic from there. So it's kind of the simplest way. We were just trying to make sure that if something goes wrong, we still have a region to serve our traffic from. Now, the other option is read local, write global. So in this case, everything that is a read, we'll try to serve it from a local region. This is good when our workloads are mostly read intensive. So say if, for instance, our client in New Zealand, when it does a GET request, we'll try to serve that from the Australian region because it's closer to the user. But if the same user sends a write request, then we'll send that to the primary region, in this case, Europe. And what we're trying to do here is just to avoid writing conflicts, because yeah, we are always replicating data from one side to the other. So if it would be the case that we would have writes here and here, it could be the problem. And we'll see next how to handle that. But in this case, this is very simple because if you have mostly reads, you serve your reads locally, but if you have some writes, you send them on to the primary region, and you will be able to have a nice system working as well. Okay. Now the third option that you have is if you have reads, but your system is mostly write intensive. You have a lot of writes. So usually one of the strategies that you might use here is to actually serve your writes from the regions in which you think are the most likely to get written. So for instance, if there was this entity foo that was created by a client in New Zealand, we might decide to store it in New Zealand and serve the rights for this specific entity from New Zealand. So maybe this is actually a person from New Zealand and is storing some personal data. Most of the time they will be in New Zealand, so that's fine. We assume that reads and writes are served from New Zealand. But then if this client actually flies to Portugal and tries to access our system from Portugal, they will still be able to have reads to read from this Europe region, okay, through the replication, of course. But if it tries to modify the data, the write will still take this long journey going to Australia region. Okay. So one simple example is if you, for instance, if you have on a betting company, if you have multiple regions and you are creating a match that is a cricket match, you probably might create it on Asia region because you know that a lot of people are betting on cricket in Asia. But if it's American football, maybe you want to create it in America because a lot of people will read and write and do bets on that context. Okay, so this depends a little bit on, of course, in the knowledge of your business. Okay, so third point is, of course, knowing your dependencies, the dependencies of your service. So we'll want to map what exactly are the internal and third-party dependencies. If you are using the cloud, you will also want to understand exactly which services are available in each region, because sometimes some services that you might be using might be available in one region but not in another one. So it's good to check that. And configuration dependencies, certificates, keys, secrets, parameters, etc. So in this case, of course, we have two dependencies, the third-party service and the old legacy service. So we would want to make sure we would need to think about what we do with those. So the goal with the dependencies is always, in theory, we always want to avoid cross dependencies between the regions. So apart from replicating our data, we're trying to avoid having any kind of cross-region dependency. So in theory, if we can, we would try to make sure that our third-party service somehow is deployed also on this region, or our old legacy service is also deployed on this specific region, so that if there is actually a problem on this region, we don't want to actually have some cross dependencies. This is the what it should be in theory. In practice, it might not be so simple, because you might decide that, well, if I have a very big outage, maybe this third-party service is not critical for me, and I decide that I don't need to have multi-region for this service, or I need to replicate this old legacy service for this side. It depends a lot on your business and the way, if these dependencies are actually critical, how critical are they for your services. But you need to think about it, of course. Now, about configuration, you obviously need to think about certificates. Hopefully this comes back eventually. But you need to think about certificates. For sure, you need to think about certificates and keys and secrets and container images. And you want to make sure that those are actually, let me just try to turn this on and off, I guess. Let's see. No, it's tires. Okay. Yeah, but one thing that I can say right away is, yeah, make sure that anything configuration-wise that you use on one region, you want to make sure that is available from that region, right? Because you don't want to, again, have needing to fail over to one region and then having to depend on something that is now not available because you are having a big outage in the other region. And one interesting thing is, for instance, expiration dates on certificates. You want to make sure that those are different between the regions, of course, and also you always use different keys and secrets per region. Okay, now I really would like to have an image to show. Let's see. Okay. Well, maybe I can talk about this fourth point. We'll have to get creative on it. It's not an image, so it's just a list of things that we want to think about. So I think I can move on with these without issues. So the fourth point is actually operations. So basically, you need to understand how to operate your application. For instance, say you are deployed as an active passive, so you have one primary region, one standby region, and you need to fail over. You need to make sure that even on your on your standby region, there are good service quotas and there is the ability to scale up to the required workload. Otherwise, it might be the case that your standby region is there and you're not using it. It's just there waiting to be used. But then when you try to use it, it's not available to scale up to the required workload that you are trying to put on it. So you need to make sure that specifically if you are using active passive architecture, make sure that you have good service quotas and the ability to scale up. Also, when deploying, okay, we're back. Okay, good. So when deploying, make sure that it's kind of obvious, but you're probably good to do one region at a time. It might be that you prefer to deploy first to the passive region, and if you have an ability to check if everything goes well, or another option could even be to deploy first to the active region, because if something goes wrong, you might fail over to the passive region. Of course, for your operations, you also need to have good observability. And one essential thing there is the replication lag, for sure, because now you have this big link between regions, and you need to make sure that you know exactly how is the lag between different regions. And yeah, local alarms and metrics. So if we are operating in different regions, make sure those are configured in the local region. Another interesting thing is knowing what is the process and the procedure for failure. In my experience, usually the failover process itself is automated in the sense that you can go ahead and click on something to make it shift to that other region, but usually the decision is made by humans. It might be, for some cases, it might not be. It might also be automated, but in my experience, usually the decision itself is made by humans. Yeah, and then obviously consider the cost and complexity of operating this type of architecture. So I wanted to go a little bit deeper into this failover and show you four different levels of failover that you can have. So you can fail over on a component level. So say we have our services, we're having issues with our message broker. In theory, we could decide to just fail over this specific component, and instead of using our message broker that is in Europe region, we start using the message broker which is in the other region. Of course, we know what will happen. We'll have a lot of latency on these writes. It might be the case that we even need to modify our configuration and redeploy our services. It depends a little bit, but it's definitely a possibility, and it would be a kind of very flexible and autonomous way to failover. Another option is to failover on the individual service. So if you're having issue on this broker, the service is not behaving as you want, you might decide, okay, I will failover this service to the second region. And then, yeah, we do a change on your global routing and your traffic starts being sent to the other region for this service instead of being processed here. And of course, there you will be using your local message broker, your local database, so the behavior itself of the service will probably be fine. The problem with this approach is that now when you zoom out and you typically have not only one service but multiple services, so say you have a service A that uses a service B and a service C, when you are failing over this service specifically to the Australian region, now it might be the case that this service A is already on the Australian region, but this service B is still being operated from the Europe region. So you might start having cross-region connections because your services depend on each other to do whatever they do. So, and this leads us to the third type of failover, in which you kind of map all the dependencies into, so say, business capabilities or user stories, so that you know that if you need to failover because you are having an issue with service A, then you decide to failover also service B and service C, because you want to make sure that these interactions, these dependencies are all served within the same region. The problem is here, obviously, you need to have a good understanding of the overall system that you are operating. It might be the case that these belong to different teams, different departments. It depends a little bit. So it requires a good understanding of the overall picture of your business to be able to map these different dependencies and fail over when it's needed. Of course, the last option is actually, yeah, we're having issue with one service. We don't care. We just fail over everything. So, and we just decide to, yeah, we'll fail over everything to the new DC, and we'll start serving everything from there. And the problem here is that most of the times on these kinds of organizations that need this type of approach, these different services belong to different teams, but also different services don't have the same criticality. So it might be the case that for some cases, for some services, you want to have multi-region capabilities. For others, you might decide to not have it. Or for some, you want to have active-active. For other ones, you just decide to have active-passive. So yeah, just failing over the entire protocol, it might not be, might work for some cases, but you need to also taking that into account. Okay, so we went through these 4 things that you need to understand about your application if you want to go multi-region. But the devil is in the details. So, and I've kind of went around some of the details in purpose. Mostly, I didn't provide many details about the global routing and the long-range replication. So, and before I go into this, are there any managers in the room? Managers? Okay, so we're safe. I'm allowed to do this joke, and and I also know Padilla, so it's fine. Yeah, because when I was doing this diagram, I was thinking, yeah, I'm simplifying all these 2 things that you might use. And I was always wondering if there was a manager hearing this talk, and tomorrow they would go to their team and say, yeah, folks, we're going multi-region. I saw it yesterday. 1 box at the top, 1 link at the bottom. How hard can it be, right? I mean, let's do it. I'm just kidding. Okay, I know. Developers can get as excited as managers, so I know. Yeah, so we'll talk a little bit about these 2 specific missing details. So one is the global routing. And this will kind of split into the external traffic routing. So this kind of, there are a lot of solutions that they can use for this. Typically, you will use something that allows you to route your clients based on the geolocation, for instance, or can have other types of routing. But in this case, the cases that we've been using, it would be something like this, right? So you get your user in Portugal, then the for this global.app, it would be resolved to this EU service A global app, because this user is in Portugal and we have a Europe region that is closer to Portugal. So this solution would automatically resolve that. And actually, based on the path, you can also configure it to redirect to a specific service. So this is kind of fine. It will also do for you the probing and failover traffic if you want to. So these global load balancers will probably, you can configure some probing, and automatically, if there is issues going around with this service, it can automatically fail over to the other one. So this is something available easily. Now, where it gets more tricky is when you're trying to redirect internal traffic, in the sense that you're trying to decide if, depending on if this is a get a read request or a write request, if you need to decide to which region you will send that traffic to. So then there are not very out of the box solution for this, because you need to do that kind of logic somewhere around your service. Might not be your exact service, might be an external service that you need to implement to do that, but you need, when you're receiving your service, your request on the service, you'll need to decide if this is the service that is handling write requests, or if I need to actually redirect that to my other region that I have. And it gets even more complex if it's not only a matter of I'm handling writes or not, but if this service is only handling writes for a specific amount of entities, and you need to decide, yeah, do I handle this write for this entity, or do I need to redirect the traffic somewhere else? So this is one of the things that it's probably an extra service in itself. More missing details is around the replication, right? So we talk a little bit about the async replication, and there's probably different ways you can do to replicate your data from one region to another region. Maybe you, for some use cases, you can simply have scheduled snapshots from this database and restoring it in the other database. That might work for some cases. Maybe you have a pipeline with change data capture, and you are kind of listening to the events, the written events, the changes on the database, putting that in some Kafka and replicating that to the other region and applying it on the DB on the other side. Or maybe you just use some out-of-the-box DB solutions that do this kind of replication for you. In all of these scenarios, the common thing is that once you start using async replication, you start having on the rest of the application, you start needing to use some of these things like retries, idempotency, deduplication, which sometimes, or at least in my experience, lead to the use of event-driven applications. So, and this is where I think, or at least from my experience, event-driven applications tend to make it multi-region applications easier to deploy, because by default you are already enabling async replication for performance and availability. You are already promoting the regional isolation and preventing correlated failures, because you represent your data as independent events that are not coupled with between services. And yeah, you simplify data and state management. Your data are the events, and then you can, from those events, build up your state how you want. And you are, of course, already managing eventual consistency if you're using some of these event-driven architectures. Now, what Also, the other thing that this allows is we've been talking about replication on a database level, all right? But what this also allows is if we have a system like this where one service receives your requests and is writing to a message broker, and then another service is reading from the message broker and writing to a database, actually you might not want to do the replication on the database level, and you might actually do the replication on the message broker level, for instance, because you try to replicate at the top and then you just maintain the two sides of the system completely independent. You don't want to have dependencies on the database even. You just replicate at the top and then let them work out independently in both sides. This probably works fine in cases in which there is more like a streaming pipeline, but yeah, depending on exactly your use case, might make sense for you to think about, yeah, if you need to actually do the replication on the database level or if there are other options that you can use. Now, another thing that I haven't mentioned, it's also a very important missing detail, has to do with conflict resolution. So if for now, we've tried to avoid having rights for the same entity from different regions, but that can happen either because, yeah, we just couldn't avoid it, or because when we fail over from one region to another, and then the old region comes back online, there might be conflicts between the data because something was written to one database that went down, and now we are not able to reconciliate. So usually what the DB providers give you is the last right wins strategy, which is basically accepts the last information as the real one. But in practice, it might be the case that you might need more sophisticated logic. And in those cases, you will usually have to implement that yourself in the application. It could be the case that you just want to send the conflicts to some queue for manual processing, for instance, or you do some kind of resolution that uses some other factors like a more sophisticated logic to do these types of conflict resolution. So when the last right wins is not enough, this is when replication needs to be a first-class citizen. And this is what actually we've been working on at ACA for some time now. And how do we help users fix this is, for instance, for anyone that doesn't know, ACA is based on the actor model, and it's event-driven by default. It provides multi-region. But the interesting thing that I wanted to show you here is that, for instance, we provide annotations for effects. So when you're declaring your entity, for instance, it's an entity, you can say that a certain operation is marked as read-only. What this means is that for this operation specifically, I can serve it from any region. So if it's a read-only operation, ACA will be able to serve it from any region. Any other operation will need to be redirected to a specific region that is handling the rights. We also offer other things like filtering capabilities that allow you to filter the data that is replicated to the regions. And another interesting thing is this pin region versus request region primary. So the pin region primary is pretty much what we saw with the read local, write global, where a client in New Zealand will create this entity foo in this region, in Australian region. And if there is a client in Portugal that tries to do some modification to that entity, the request will go locally to the ACA service on this side, but then ACA will take care of redirecting that request to the other region. Okay, so this part of internal routing that I was talking about is done internally by ACA to send that over to the other region, and it also takes care of any kind of replication that is needed from the two sides. Now, the other option is also to have request region, and I think this is the most interesting one, in which if you created this foo entity on the Australian region, but then a client in Portugal actually does a write on the Europe region, Akka will automatically fetch the latest state from the home of that entity and rehome this entity to this Europe region. So allow you to start serving writes on this region instead of the other one. This is useful when, I don't know, if you have cases in which you're serving some clients but they drive or move to another state and now you want to serve local writes from that state, this will automatically do that for you. Okay, so I just want to end by elaborating some reasons why not go multi-region. Obviously, the costs will be like very significant, so you need to make sure if you don't have the budget, you might need to make sure that you consider this. The operational challenges, of course, there'll be a lot of them. And if your app is unreliable on a single region, yeah, just make it reliable first in a single region before going multi-region. Yeah, just the summary. What should I remember for tomorrow? Yeah, you might not need multi-region, but if you do have goals, obviously understand your application, your boundaries, your constraints. Try to avoid the cross-region dependencies at all costs, and yeah, practice your operations. And of course, many of the decisions that you might take will be based on the business itself, so you need to actually know the business. And the last interesting thing I think is that most of the resilience principles that you use when building one single region application is kind of similar to when you are building a multi-region application. Yeah, if you want to learn more, there's a nice demo about multi-region with Akka SDK. And there's also this interesting blog post, Global Sharding by Meta Engineering. I found it a very nice read. Of course, documentation on GCP and AWS is also very good. And there's also the CRDT technologies, which also was created also by a Portuguese guy, an academic folk. And it's very interesting when you have multiple writes in different regions, there's some way to solve the conflicts. Or just go to, yeah, Akka Docs. We also have some information on multi-region that you can consult. That's pretty much it. Thank you guys for coming, and thanks again for the opportunity. If you have any questions, let me know. Thank you.